Hello and welcome to this session about pressure. So looking at these two pictures, which one exerts the greatest pressure? Picture 1 or picture 2? Well, if you know anything about pressure at all, hopefully you've said picture 1, because pressure is exerted whenever a force is applied over an area. Therefore, the smaller the area, in this case the end of the finger, compared to the whole hand, have the same force but over a smaller area, so therefore there'd be greater pressure. This is the reason behind why if you push your finger into a wall, it doesn't go into the wall, yet if you use the same finger to push a thumbtack, the thumbtack will go into the wall, because there's an even smaller area of which the force is placed upon, so therefore there's greater pressure. Same thing with a sharp knife or a dull knife. A sharp knife has a smaller area, so it's more effective for cutting. So let's put this into a little bit of maths. We look at pressure. Depends on these two things: the amount of force applied and how big or small the area is. So it'll be calculated as pressure. Newtons per meter squared is force in newtons divided by area in meters squared. And we can use this simple calculation triangle if we need any help. A little note here that newtons per meter squared is a unit we don't often use. More commonly we might use the term Pascal, okay? But Newton per meter squared or Pascal is the same thing, okay? So just be aware of that. That's how we can calculate pressure. Let's think about gas pressure. So in this tyre there's not enough gas pressure, so it is flat. This tyre is fully inflated because there's enough gas pressure. Now, to think about gas pressure, we need to think about the gas molecules. Now, pressure here is caused, the force involved is due to the collisions of the particles on the outer surface of the tyre. Okay. So what we have is due to the change in momentum that causes a force, and if there's enough force applied, that provides a suitable gas pressure. If there's not enough particles, so such as in this case, there's inadequate gas pressure, and therefore my tyre is flat. In this tyre, I have more particles, and therefore they provide enough collisions with the outer surface of my inflated tyre to provide the pressure to maintain its shape. So that is gas pressure. We need to think about something called atmospheric pressure. Okay, so pressure exerted by the gas mixture we call air is called the atmospheric pressure. And the atmosphere that surrounds the Earth is a sea of air, and what it does is it exerts a force on the surface of the planet. Okay. Now what you feel, the atmospheric pressure, is the force of the column of air and the force of gravity pushing down on you at sea level. Okay, so at sea level we have what's described as 1 atmosphere of pressure. So this is pretty much the standard pressure which we feel on planet Earth at sea level. So that's something which we live with all the time. The first person to start measuring this was, I've got to get this right, Evangelista Torricelli. And what he did, he recognized that there was an atmospheric pressure, and what he could do is that he could balance that out. And what he'd do is, by creating an empty space in a tube and having a column of mercury, what happens is that the amount of pressure pushing down would be equal to the weight of the mercury in the column. So those two forces would balance out. Now this meant he could work out that at sea level, atmospheric pressure, this was able to support a column of 760 millimeters of mercury. Now this origin of making measurements of pressure was one of the reasons why we sometimes, if we think about barometers, we talk about pressure with respect to millimeters of mercury. In fact, there's lots of interesting ways which pressure is measured in. I'm going to mention some of these just in case you're looking at any books and you go, what is that on about? So the pressure of the tyre, PSI, this is pounds per square inch. What is this in atmospheres, torrs and pascals? So these are 4 different ways to measure it. PSI is pounds per square inch, so 1 atmosphere is equal to 14.69 PSI. And therefore 28 psi times 1 atmosphere divided by 14.69 means that 28 psi is 1.9 atmospheres. We recognize there's a unit called the torr, and 1 atmosphere equals 760 torr, and that can be translated across to, in this case, 28 psi is equal to 1.4 times 10 to the 3 torrs. And finally we have the Pascal. Okay, so 1 atmosphere is equal to 101,325 pascals. And again, 28 psi is equal to 1.9 times 10 to the 5 pascals. So just be aware there's some different units out there, but in the IB we'll be using newtons per meter squared, often described as Pascal. The first person to start investigating this, an Irish scientist called Robert Boyle, was interested in how pressure impacted volume. So what he did is he changed the pressure and did some studies to see how it impacted the volume of a gas. Now, from his measurements, he discovered a couple of things. First of all, he discovered that there was an inverse relationship here. They were inversely proportional. When one increases, the other one decreases. And that means that pressure times volume, normally if multiplied together, comes out as a constant. And this came as a result in Boyles Law. Pressure, volume, and K, which is a specific constant at a specific temperature, always equals the same number. And that means if you have two gases where the temperature has been the same, pressure 1 and volume 1, if I change the pressure, I should be able to work out the volume, assuming the temperature is kept the same. Examples of this would be if I have 250 centimeters cubed of an ideal gas and they're compressed at a constant temperature, what atmospheric pressure, from atmospheric pressure to 200 kilopascals, what will the volume of the gas be at the new pressure? So take a moment just to work with some of those units and do some transformations. And how this should have been calculated is we recognize that if we have 101 kilopascals, and that's the 1 atmosphere, and we've got 200 kilopascals times 250 gives me an answer of 126.25 centimeters cubed. Now please note here that I did not need to change the volume into meters cubed on this occasion, because as long as I'm consistent with what units I'm using, then I can use different units of pressure, as in not always the Pascal. I could use atmospheres if I wanted, I could use Pascals if I wanted, as long as I'm consistent there, and my volume will come out as consistently as well, as long as I'm using centimeters cubed all the time. Another example, if a gas at a pressure 56 torr and a volume of 1.5 litres, what will the new volume if the pressure is increased to 150 torr? Okay, so think about that for a moment. We're assuming that the temperature is constant. So here we go from 1.5 litres to 0.56 litres. It's been compressed down. So that's an overview of pressure. I hope that was useful. So, thinking about pressure, can you explain this? Look how the hole at the bottom of the bottle seems to spray water out further than the other holes higher up. The reason for that is liquid pressure. So pressure acts in all directions and pressure increases with depth. Therefore, we have a low pressure at a low depth and a high pressure at high depth. And this pressure can be calculated as the force of gravity multiplied by the depth multiplied by the density of the liquid. So that's why we have the highest pressure at the greatest depths. There is an overview of